Gentlemen, good afternoon and welcome back to the shop. Today I'm going to be discussing the final results of my 3D printer enclosure series. Let's get started. Basically, the way I'm going to go through this is I'm going to go through each item of why I started this project in the first place, and I'm going to discuss how the enclosure has changed that item and changed my experience with the printer. Starting off, the main number one reason why I actually felt the need to do this in the first place, the need to do it, is because I needed to print polycarbonate parts. Polycarbonate is one of the few plastics that you cannot print without an enclosure. ABS is what I print most of my parts in right now, and in fact it is similar but not the same in that an enclosure is recommended but not required. The next issue was to control warping and dimensional accuracy. This point and the first point are kind of connected in that ABS and especially polycarbonate love to warp and change shape after they come out the nozzle and cool down. And this is why it's recommended or required that you have an enclosure so that you can bump up the temperature, control the environment, and sort of minimize that change of shape. One of the symptoms of this effect is the parts will start physically curling like a banana on your bed and peeling off in the corners. And a lot of the times this will lead to the parts actually coming straight off the printer bed. And in fact, currently I notice this in all of my parts, but that's because of separate factors that I'll get into later. We'll just take a quick pause here and I'll show you what I'm talking about. So you can see the shape on the ends of these test parts, and you can see the one on the right is significantly more curled than the one on the left. This was printed at room temperature. This was printed in the enclosure at 50 degrees Celsius. There is still warping present on this one, but it is significantly reduced. Now, as for why the parts warp, when the first layers go down, or any layer for that matter, they're extruded at very high temperatures, and then the plastic begins to cool and solidify. As it does that, it shrinks. However, when you're printing on top of layers that have previously been laid down and have already solidified, those have reached their final shape already. So when you print a layer down and then it shrinks on top of it, it pulls the top together, and as a result it curls like a banana. The enclosure helps because it keeps the plastic warmer than it otherwise would have been, thus reducing the shrinking. Now, the next major point on the list is the noise. Generally, this is a pretty quiet shop. There's really only two items that produce significant noise in here, or really any noise at all, and that's my mini fridge and my mini split. The mini fridge and the mini split are both pretty quiet, so generally it's pretty quiet in here, except for this printer. This printer, however, produces a lot of noise. In particular, a sort of high-pitched, whiny fan noise, as well as the humdrum of the motors accelerating and decelerating. I can say that this enclosure has significantly reduced that as well, both because of the concrete slab sort of absorbing that low rumble and the wood and glass blocking the vast majority of the high-pitched fan noise. Now I'm very comfortable with having this thing on while I'm in here, whereas before it would distract me from my work and it made it very difficult to focus with such a high-pitched noise in the background. So I'll show you the quantitative results, but it should pretty much give you the picture of what I'm talking about. Returning back, dirt, dust, dirt. This is a fairly clean environment. However, we still get dust coming in from the outside a little bit, just from the air. I still have dust coming off of myself in the form of skin flakes and the like. I still have a significant amount of clothing fibers being shed off of my clothes. And that leads to a small layer of dust coating every horizontal surface in here. Because primarily the bed, which is of course a perfectly horizontal surface, it needs to be perfectly clean, otherwise the parts will not stick. Even a day's worth of dust, or even less than that, can cause problems, such that every single time I print, I basically have to clean the bed. Aside from just that, there's also many grease parts on the machine that tend to be very sticky. So if they get exposed to dust, dirt, particles, or debris, they will collect them on those surfaces. And when the rollers and other moving parts move across those surfaces, it can lead to additional wear as well. I can say that since I have this enclosure, it's never dusty inside. I still clean the print bed occasionally just in case I get stray grease or oil or even some small amount of dust on there. But I can say that it is no longer a significant problem. And it extends to the grease parts as well. Again, not a problem. Next up, fumes. The fumes that come off of most plastics are not very harmful. Like PLA in particular is pretty friendly, but other plastics like ABS in particular is pretty bad. You know, generally it's not a good idea to breathe in any plastic fumes regardless of what plastic it is. I did notice that when I would print without the enclosure, it would start to smell faintly plastic in here, which is probably not very good for my health. The nice thing about having this enclosure is I can buckle it up, and once it's printing, no ABS fumes come out because it's airtight. And when it comes time to take it out of the enclosure, I take it out and the fumes might spill out, but usually I'm taking the prints out at the end of the day or in the morning where I'm going to be leaving the building shortly afterwards. And that gives those fumes time to dissipate when I'm not in the building. So it has helped the scent and the general sort of air quality in this place as well. So aside from just all the mechanical and functional aspects, you know, certain plastics require it, warping, noise, dirt, fumes, etc. I'm sure there's some that I'm missing too. I will say that I also appreciate the cosmetics of this. I know it's not the most fantastic looking thing because it is kind of shoddy concrete and Home Depot plywood, which is not famous for looking particularly good and is pretty how you're doing, but I still think it's an upgrade over having the bare printer. I think that about covers all the points of the reasons I did this project and my results in those regards. Next up, I'm going to talk about what went wrong, i.e. what would I change. Now, a lot of that stuff's already listed up in earlier videos, so I'll just quickly glance over that. On the other hand, there are some things that have not been discussed, such as a couple of failures, electrical failures I actually had after this project was finished, as well as some design changes I would like to make to this top assembly now that I've had some experience with it. If you remember my first video, you will recall that there were many problems with the concrete slab, one of which has developed over time. This concrete slab is actually no longer flat. This hasn't really affected anything on the printer, but it is something to keep in mind when using custom concrete. So if you look at this gasket here, you'll see that the gap here is kind of small, whereas the gap here is now much larger. Well, that's a combination of factors. This gasket actually exerts quite a bit of pressure on the concrete base, and these mounts are on either end, and it's essentially trying to cantilever or, you know, banana the concrete basically. Because we have all this force pushing down and then pulling here, it wants to bend the concrete, and concrete, at least when it was soft, has a tendency to creep a little bit if subjected to extensive stress. And that has happened here. Now, it's not a problem because the printer still sits pretty well on the surface, but it is something to keep in mind. Now, aside from just that issue, which has developed over time with the concrete, I will summarize all of my statements in that first video, and I will basically say that if you can, unless you absolutely have to, use patio blocks or some other prefabricated method of obtaining a concrete slab. In my case, this is a 24 by 24 enclosure, so I very could have easily gotten a 24 by 24 slab. It was kind of foolish of me to attempt this when there were much better options available. The next issues were of an electrical nature. I had multiple connections fail due to thermal overload. Now, the first instance of that was the switch, fuse, and input power block in the rear that has many crimp connections on it. Now, it failed due to a variety of factors. So firstly, there's a 10 amp fuse in there. I was pushing 800 watts, so maybe several amps. That fuse should be able to handle it, and it is. But you also have to consider that it's inside an enclosure which is raised up to 40 or 50 degrees Celsius. That also is a factor as well. And on top of that, the fuse is actually, well, a fuse is basically a resistor, right? So the fuse is adding to the heat locally by dissipating heat, so that the temperature of that section there, both due to the fuse dissipating heat, the extended temperature of the enclosure, me pushing more current than it might have been rated for, basically caused a thermal overload. And one time I came in here and it smelled kind of smoky and the printer wasn't running, and I looked in the back and I saw a couple of the connections were cooked. So that's another thing to keep in mind, is when you raise the temperature, you have to start worrying about things like that, or when you overload them or put more into them, etc. The next instance of a failure I had was in switches that were more than rated for the current that I was pushing through them. The problem came in the installation when I directly soldered two 14 gauge wires onto the little switch terminals. And in doing so, because my iron wasn't hot enough and I spent too much time with the iron on the switch, I actually heated the switch up a little bit and partially melted the plastic, which caused the geometry of the connection to be wrong. And that, combined with the added heat in the enclosure, meant that eventually the switches cooked as well, and I came in here and it smelled like, burnt plastic and electronics. A smell that you'll be very familiar with if you do a lot of work with electronics yourself. That's another thing. To resolve that issue, I reinstalled switches, but I crimped on the connections instead of soldering them, and that would ensure that I wouldn't overheat the connections or damage the switch in the process of soldering them, because I wasn't soldering them. And since then, I haven't had any issues. The next one, I wouldn't really call it an issue. It's just something I want to point out. But if you put on an enclosure like this, be aware that you might have to move your drag chain. Otherwise, it can collide and rub against the wall of your enclosure, which can seriously mess up the geometry of your printer. I addressed it simply by moving the drag chain from the wall that it was colliding on to the opposite corner, and that solved all of my issues. As for issues that I've had with this directly, that covers it. The next section is just things I would like to change. The first change sort of addresses the concrete issue. If I had to do this again, I would absolutely go with a patio block. The next change, this is actually made out of 1/2 inch plywood. I would bump that up to 3/4. But the number one reason is dimensional stability. So I had issues with this plywood in that it was warping and in shifting around and such. And basically that meant that my door wouldn't fit because the frame wasn't square. If I was using 3/4 plywood, those problems wouldn't be as severe. And not to mention, it's easier to secure hardware to 3/4 plywood. It's just more sturdy. Next up, insulation. So this enclosure isn't actually insulated per se. I mean, the wood does provide a lot of insulation value. The concrete is really poor in regards to insulation, but it is at the base of the enclosure. So where all the action's happening, high up, that remains hot. This thing takes quite a decent amount of energy to keep warm, maybe a couple 100 watts or something, and it can really add to the power consumption and heat of the space. So going forward, if I were to do this again, I would bump up the size of the enclosure, and I would buy foil-faced insulation, polyiso. You can get it at really any building supply store. And that would add reflectivity and give it a space-age look, reflecting back the infrared that the printer was emitting. But not only that, it would also add to the thermal insulation in keeping the walls colder and making sure that, the printer doesn't have to work as hard to keep it warm in there, reducing power bills and the like. Now, the next thing was the door. I actually had quite a bit of issues with the door. It's working now, and it's not perfectly sealed, but generally this glass plate has added a lot of rigidity to this plywood frame, but I would say that it's still inadequate. Going forward, I would upgrade to like proper thick 1 by 2 by wood, say 1.5 inches or whatever, or 1 inch wood, to get that dimensional stability. Or I would move to say a 3/4 square steel tubing frame and then attach my stuff to that. And that way I'd get to have a door that would remain flat, hold tight against the seals, and wouldn't warp or leak at all over time. Another thing I might do is change the construction of the printer entirely. It's actually very popular for people to build aluminum framed enclosures with polycarbonate sheets. I'm not a fan of that because of the poor insulation value, but I might consider building a steel framed enclosure with polyiso insulation making up the walls of the enclosure. And that way I could kind of have the best of all worlds. Very rigid construction, not super big, very good insulation, excellent dimensional stability, etc., etc. So gentlemen, thank you for watching the video. I think that covers all of my results, concerns, changes, issues, you name it, it's done. In the future, I'm going to be doing some other upgrades to my 3D printer. But in the meantime, I would encourage you to, if you have any questions, post them in the comments section below. I'd be happy to answer them. If you liked the video, drop a like. If you think anyone else should see this, share them a link. It helps out the channel. And otherwise, I will see you next time.